In this video, we are going to talk about electrolytic cells, also electroplating. They're basically the same thing. There's different versions or different types of electrolytic cells. Electroplating will be this video. I'll discuss the next two in the next video. But basically, this is where gold-plated jewelry comes from, or silver-plated jewelry, or if you wanted a chrome-plated like a car part, like cars that have lots of chrome on them, or motorcycles. Those are not solid chrome pieces. Those are metal or steel or iron, and then they are typically chrome plated because the chrome looks nice, but the chrome isn't very strong, and so you need an iron core or a steel core in order to make the wheel strong enough to be usable. But then you want the chrome on the outside to make it pretty looking and shiny. So that's where all this comes from. Now, we use a lot of our battery terminology here. We are going to have an anode and a cathode and things like that. But before we get to that, think about what's happening. We want to take silver and we want to put it on, this is my version of a Vork, like if you had silverware that was silver plated. I know it's a terrible drawing, but this could be a car rim, or it could be a piece of jewelry, or it could be anything that you want to put a coating of metal on top of. This is going to be your red cat. It's going to gain mass. Basically what we're going to do is we are going to put a thin little layer of gold or silver or platinum or whatever you want to put on it. We're going to put a thin little layer over all the parts in order to make this our, metal plated jewelry. Therefore, it's always going to be the red cat. This one is always going to be then the anodes. Another name for these anodes are actually called sacrificial anodes, because essentially we're taking the metal here and sacrificing it to go to there, okay? And that's pretty much it. So we actually answered most questions. We know this is where reduction is going to happen. This is the name of this is the cathode. It's going to gain mass. This is the anode. It's where you're going to lose mass. It's where oxidation occurs. Now let's look at how it happens. So you put these things in a solution. So we have a solution of salt, just like in a battery. The salt solution, it has to be the salt. The salt has to contain the metal that we want to plate. So in this case, we want to plate silver. So I use a silver salt. When I put it in water, it's going to break up into Ag plus 1 AQ and Cl minus 1 AQ. We don't care about that part. And now let's plate it. So think about this. We want to get the silver ions to the fork. So the silver's positive. Notice the fork is connected to the negative part of the battery. And the reason we put the negative over here, so that way the silver gets attracted, gains an electron, and becomes Ag0, that's solid silver, on the surface. So we need that to happen. Now, what would happen initially is we would just use up all the silver ions that are in the water very quickly, and we wouldn't have enough. So the way we do it is we replace the silver ions with the silver electrode. Every time the ion leaves the water, you're going to get new ions that are coming out of the bar and coming back into the water to replace them. So the Ag0 over here, this is solid silver again, and over here it's also solid silver. The zeros are always the solid. It's going to be dissolved over time, and the bar eventually will totally disappear, and it'll create silver ions. Guess what? Once you understood that, we're done. If you look at it, we have our two half reactions. Take a look. The oxidation half reaction is the one where it's losing electrons. Well, this silver became this silver by losing electrons, and the reduction is gaining the electrons. Well, this silver, I'm going to try to like half highlight them to show you that it's actually the same thing, went over here and became that one. So for reduction, let's do oxidation first. We have Ag0, that's this one. It's going to turn into Ag plus 1 plus an electron. That's this. That electron went through the wire to go over to the fork. Then the reduction happens, and we have Ag plus 1 gains an electron. In theory, it gained the same electron that this one gave up, but not really. So it gains an electron, and it becomes Ag0. These zeros are the solids, and the charged ones are dissolved in water. There's my two half reactions, And with this type of reaction, they're always going to be balanced, but I'll do it anyway. They're both 1s, but you really don't have to worry about it here. It requires a DC power source, that's a battery. It has, if you notice, there's no half cells, there's no salt bridge, there's no need because everything's in one large container. The salt bridge is to prevent charge buildup, but since everything's happening in here, there wouldn't be any buildup anyway. There's no half cells, it's one giant cell. The charges on the anode and cathode are actually reversed. So normally, the cathodes are, in a battery, the cathode is positive, the anode is negative, because cathodes make cations and anodes make anions, words we should know, okay? But since we're using a battery, this is only in a battery circumstance. In this case, we're using a battery to power something else that's not a battery. The charges get flipped. And then the last part, electrolytic cells. They use electrical energy to make chemical reactions happen. So they convert electrical to chemical. This would also be what you would need to do to recharge a battery, to make it go backwards. But this is one version of an electrolytic cell. There are 2 others that I'm going to talk about in the next video. They're also very short like this.